Hi everybody, very warm welcome to this webinar on the comparison of Spark and MapReduce. This is Vishal and I hope everybody is able to hear me, right? Let's then just directly come to the, the topics on which we plan to invest our next 1 hour. I am taking this opportunity as the investment of your time in terms of basically getting some value out of it. And well, I feel that if we just talk about MapReduce, well, here I'm going to take a certain kind of assumption or advantage that at least you guys are aware what MapReduce is from the paradigm perspective. So, well, beyond MapReduce, why do we look forward for it, right? We'll take a very quick stab on those lines. And then when people say that Spark is better than MapReduce, there are statements like Spark will replace Hadoop or Spark will replace MapReduce one fine day. Uh, you know, is there a basis or what exactly is a fact altogether? We will talk about on those lines. Uh, then uh, benchmarking of Spark versus MapReduce or analyzing data with Spark, basically these two things. So as you know, I'm not sure how many of you have already attended some of the sessions or webinars with Edureka, but our webinars are typically associated with hands-on. So we firmly believe in walking the talk. And hence, if the webinar says Spark versus MapReduce, at the end of the session, probably last 15-20 minutes, I would like to dedicate wherein we would be doing a very quick hands-on. We will take a good amount of data and we will fix a machine. We will run MapReduce job, the conventional MapReduce job. We will see the time. Then we will keep the data as it is. We will initiate the very same process on the very same machine on Spark. And then we will see the execution time in terms of the performance, right? And of course, it goes without saying that they both should be producing the same output altogether. So the input is same, the machine is same, the RAM and everything is same, just that one would be on Spark, one would be on MapReduce, and then we should ideally, so the idea here is that you should be comparing apples to apples. Looks like a good use case? Looks like a 1 hour worth spending to you guys. What do you guys say? And then we'll basically be of course I'll be taking some questions and all in between wherever it is possible, right? Are we guys good to go? Great, thanks a lot for quickly confirming, guys. Sure. So how many of you have seen, or how many of you do know this code? I have not even given you the problem statement. I have not even given you any background about it. But the very fact that you guys are attending this webinar, I just want to know from you guys, how many of you have seen this code somewhere and what this code is about? Right? Exactly. Yes, as Anant, Munish, Don, others are saying, it's a hello world for MapReduce paradigm. And what is the hello world for MapReduce paradigm? It's the simple word count program, right? And what is the word count program? Eventually, at the end of the day, it's a group by count, right? In the SQL world, it's a group by count. And in the world of, Java and all, it's all about grouping, creating a map, and then eventually, just running out the things, right? Well, my intention is not to discuss word count and its algorithm at all, right? This was just a reminder that yes, this is the smallest or the shortest program which you can probably write, because here your mapper, reducer, everything is within one class. Okay, so probably yes, this was MapReduce, and everybody knows about it. That's not the direction where I want to discuss. So let's quickly talk about Spark. Okay, so before I come to the performance comparisons and other stuff, I'm sure as some of you have already tried that some of you are new to Spark or you don't know about Spark probably. So very few quick minutes about one line definition altogether. And I'm going to literally read it. As of now, I was not reading it from the slide, but right now I'm going to read the first line for you. It says Apache Spark is a general purpose data processing engine with in-memory computing. Okay, fine. Guys, all I want you to do is, in this line, for some time, can you mute in memory? Can you omit in memory? And then try to read this line. So Apache Spark is a general purpose data processing engine with computing capabilities or distributed computing capabilities, probably. Does it remind you of anything? Does that statement without in memory remind you of anything? Specifically the people who are already working in big data domain. And basically guys, this is my idea of keeping the session as interactive. I don't really want it to be a monologue. I need your active participation, right? And it reminds, as many of you have replied already, that it definitely goes in the direction of Hadoop. So by now, I hope most of you or all of you would have figured out that the key differentiator between Hadoop and MapReduce is the nature, in-memory nature, right? It's the in-memory nature which is different between Spark and MapReduce. Spark processing is in memory as compared to Hadoop processing, which is based on disk. Okay, so I think there are some questions wherein people say, what is in-memory processing? Well, guys, the simple processing which you do typically, how do you process a given file? So I think this was a question from Satyanarayan, wherein he said, what is the this in-memory processing? So Satyanarayan, I'm assuming, let's say if you write a simple program wherein I ask you to process a particular file which is present in your hard disk, what do? You load that particular file, you pass through the file and eventually load the content into some collection, right? It might be a list, it might be a map, it might be something, right? And then eventually you manipulate that data or that collection altogether. Am I right, Satyanarayan? I hope this is something which you would have done, right? Almost every language does this. And this is what your in-memory processing is, because you load the content into the memory and then you go ahead and manipulate it, right? Spark does the very same thing. However, when it comes to Hadoop, it works in a bit different fashion altogether, right? So yes, coming back to the point here, it's about distributed in-memory computing. It's not just in-memory, because if you say in-memory computing, it is centralized. The differentiator here is it's the distributed in-memory computing, and when it comes to that, uh, the backbone of all of the operations of Spark is something called RDD, Resilient Distributed Data Set, and it is your kind of an abstract which takes care of the data which is distributed in memory across the machines. So that is something which is taken care by RDD automatically. Okay, it is not just the caching, it's not the simple caching, Vikrant, others. Okay, yes, it means RAM for sure, Vikrant, but when it comes to that, we are not talking about the RAM from a single machine. Okay, that is the differentiator. Vikrant, others? Okay, so now I'm just going forward. I can see there are some questions like, is Spark best for batch processing like Hadoop? How can it load the huge data in memory, specifically if the data is very huge, right? Guys, you will get the answers very soon. Okay, you'll just get the answers very soon, because that's the direction where I'm moving naturally. Okay, so now this is about just the definition part of it. Well, apart from this, right, this definition, the main or the USP of Spark is that you can, okay, um, you can process the data using Spark, either using the core API of Spark, and the core API of Spark is written in Scala. So the Spark itself is written in Scala language, and hence in our course also we cover it via Scala itself. But it's not just for the Scala developers. If you are a Java developer, you can use it. You are a Python developer, you can use it. Well, with our things have just started with the latest release 1.5, but this is still in the infancy stages. But yeah, very soon you should be seeing extensive support for R coming into picture. It is still in the very early stages, so I wouldn't count much on our side as of now. Another caution for the Java developers, like though we suggest using, we suggest using Scala, but those people who are saying or who have spent good enough time in their career in Java and they still want to continue with it, I have only one advice, that if you really want to use it, please use Java 8. Okay, don't use any version less than Java 8. Uh, because of a very simple reason, that it provides the support for functional style of programming, and that is the kind of programming which is suited best when you write the big data applications altogether. And hence is the sometimes you must have heard that Java is not really very suitable kind of a language when you're working with Spark. That's the reason. So people just say that Java, but the reality is up to Java 7 not advisable. If you really are hell-bent towards it, use Java 8 onwards. I think Munesh and others, when they were asking this question, I hope you got the answer, right? So, well, there were some questions on those lines that we heard that Java is not very suitable kind of thing, and I hope people are getting the answers, right? Okay, with that, I'm just moving forward, and so this was a very quick introduction about like Spark, what exactly Spark is, in how many languages you can work in this thing. After this, I just want to move to a very common cliche, which is there in, I think, I don't know how did it arrive, but many times people say that Spark is going to replace Hadoop. And this is kind of, I was surprised that there were some blogs also on those lines. Well, uh, they are complementary to each other, not they are not the competitor to each other. That's how I would like to put it. So Spark always was, and it is intended to enhance the Hadoop stack. It was never ever planned to it was never ever planned to kind of replace Hadoop. And as people are saying, probably because it is now supporting HDFS, so Anant, others, HDFS support was there from day one. HDFS support was there from day one. So it was never ever that now it is supporting. HDFS support was there from release 0. I think whatever it was, 7, which I used first. Okay. And now you are talking about release number 1.5. So it has been more than almost 2 years when I'm seeing HDFS support. Okay, so anyway, now coming to the point, basically when it comes to this, Spark fits very nicely in the Hadoop ecosystem. And specifically when I talk about Hadoop ecosystem, whether you want to use Hadoop HDFS just as the storage, or you want to take the advantage of Yarn cluster management, capabilities and all, Spark fits very well right there itself. So Spark can read the data from HDFS, and believe me, because it's like in the actual course I would be able to cover it in a bit more detail, but right now all I can tell you is it's very easy to switch the storage systems for Spark. It's very easy. It's as simple as parameterization, not even any code change at all required from your code side. Okay, going forward, so this is where first you should remember that Spark is there to enhance, not to replace. Yes, there is a place wherein Spark comes in the direct competition with MapReduce. That is something which is true. And then there are own boundary conditions themselves for MapReduce, for Spark. I will discuss about where to use, where not to use. Of course, I can't give you the Bible here, but I can give you the guidelines in seeing that duration of 1 hour, right? But on those lines, I will give you some kind of hints at the end of the hands-on, right? But yes, there are some gray areas. There are some places wherein now there is an overlap between the capabilities of MapReduce and the capabilities of Spark. That's where you can say that Spark is a clear winner. Okay, but then apart from the common area, they have their own specialties as well. We will talk about all of that. Okay, so yes, processing the data with Spark is much easier than MapReduce and all. Basically, it is talking about the very same thing. I don't really agree much when people say that it is easy because you are providing the support for Scala, Java, Python, etc. Because guys, if you ask me, I personally, in last more than 5 years, I have written MapReduce programs in Java, in Ruby, in Python, in Scala, in JavaScript, in C++. Wow, 6 languages. So I have written MapReduce programs at least in these 6 languages for sure. Oh yes, one was in shell script as well. And R, how can I forget it? So there are 8 different languages in which you can write even MapReduce also. Okay, you can write MapReduce also in the very same thing. So this is something which so from the language side, if you keep language thing apart, the main USP for Spark program is twofold. Performance, yes, of course, performance. Next, can you look at this program? Small, this thing on the right hand side. Can you look at the very simple kind of a small program here? This is word count. The same word count which you saw. Isn't it? Well, I am not expecting you to understand the syntax right now, but the intention, word comma one, dot reduce by key, dot map, etc., probably, right? Should be sounding familiar, right? What is your opinion? What is your opinion? Isn't the development time which will be required from a developer, right? The development time from your development team itself, isn't it going to reduce drastically? Forget just about the performance part of it, right? So this is something which is, you should just keep in mind. Next, anyway, we'll see that in the hands-on part very soon. Next is the normal question, right? What is basically, so yes, we do understand the performance part of it. Yes, for sure. But when it comes to, the natural question comes is, you must have heard Spark being associated very, very closely with big data analytics, right? So this is quite a natural question. What makes Spark really, really useful with big data analytics? Okay, in order to answer that, I just want to know from you, how many of you have actually worked with the data scientists? I'm not sure if there are data scientists in this audience already. Have you ever worked with a data scientist? At least I am working already. Just want to know. Anybody? Right. So Satyanarayan is a data scientist anyway. Uh, Geetanjali has worked. Vikrant has worked. So guys, so I'm not sure what is your nature of work with them, but the kind of nature, the kind of work which I share with them is kind of pairing typically. And if at all you are in the very same kind of situation, honestly, can you tell me, do they like uh, developing this Hadoop applications or writing the Hadoop code? Do they like it? They say, keep your Hadoop aside, keep your Hadoop aside. I can do the very same thing on R, on Python, or worse, probably even the Excel sheet sometime. Okay, as I think Vikrant is also mentioning. Am I making some sense to at least those people who have said yes? Satyanarayanan, I am sure you must have said this. If you have ever worked with a engineer altogether, so-called big data engineers, right? I'm using the word so-called purposefully, right? Well, now coming to this point, why am I even mentioning about it? We are talking about Spark. Why am I going into the line of data science and other stuff? Because guys, there is a big link. Okay, there is a big link here. Uh, Spark eventually, this slide, I'm more interested to spend some more time on hands-on, and hence I would like to wrap up these slides a bit faster. But this slide will basically be talking about that the simplification of the data analysis is something which is the USP of Spark. Okay, so just I'm taking one step back again. I just said that your data scientists don't really like writing Hadoop programs and all. Why do you think it is so? Is it because they are less capable, or is it because they are not technology oriented? This is not the answer. The answer here is the nature of their work is very much ad hoc in nature. Satyanarayan, I'm hoping that I'm on the very same lines. You might be agreeing, and others as well, right? This is where their nature of work becomes quite ad hoc. They might be having some sort of hypothesis, they might be having some sort of idea, some sort of data model, which not really data model, some sort of a computational model which they quickly want to test on your data, just by sampling it or just by quickly executing it. They can't really wait by writing a code, creating a jar, submitting it, and eventually getting the output. It's too long a cycle. It's too long a cycle for them altogether. And that's the biggest hindrance, one of the biggest hindrances for the adoption of Hadoop or its related components in science world. Spark overcomes it because it provides you REPL. Okay, REPL, I hope everybody has heard about it. It's like command prompt in other languages, or in other way people call it as it's a command prompt wherein you can do very quick ad hoc work altogether without actually depending on your programmer friend who can with whom you have to spend some time, and it is abstract enough wherein just by with a very minimal learning curve altogether, still Spark is not that much mature, or rather than mature is not the right word. Spark is still not that big enough which is having like thousands of keywords. Not many, not many. So that's where you actually get a clear-cut advantage altogether, and we call it as Spark Shell, PySpark. Well, Spark are there are at least these three, which are available, depending upon the language with which you are interacting with Spark. Munish, I hope you got the answer, right? So Munish just typed Spark shell, question mark. It is not just the Spark shell, it could be Spark shell, PySpark, SparkR, any of these three, or Spark SQL for that matter, right? Well, I'll quickly talk about it. So the simple thing here is that your data analysis becomes easier. First point, there are already inbuilt libraries. If you guys would have noticed, right? If you guys would have noticed, then there were something like .map, .reduce by key, etc., etc., as opposed to writing your own mapper, as opposed to writing your own reducer. Well, that's not the only style of programming. There are other styles of programming also in Spark, but this was like just for the sake of comparison. Okay. Multilingual support, polyglot nature, yes, we do understand this. Faster results, of course, because of the in-memory nature altogether that comes. The biggest thing which comes with Spark is that it just sits on the cluster. So it kind of insulates you from the underlying Hadoop vendors. You are working with Cloudera distribution, you're working with Hortonworks, are you working with IBM, Big Insights, MapR, doesn't really matter. Doesn't really matter at all. And if ever any of you have been the part of the infrastructure teams and the budgeting, you can understand the importance of this last line. It is a big, it's like one of the decision maker points altogether wherein organizations decide whether they want to evaluate something or at all or not. Okay, so it's one of the biggest USPs altogether, which make it powerful. Okay, I'm not a very big fan of the quotes, and hence I would not like to read it, but all I would just try to tell you is that there is an algorithm called TerraSort, if any of you are aware. So this TerraSort algorithm is kind of one of the benchmarks altogether. Okay, and then with MapReduce was a champion for it anyway. So with MapReduce, within a cluster of 2,100 machines, by the way, for 100 terabyte of data, in 72 minutes it got sorted. This was kind of a, let's say, record. But the same data with 206 EC2 machines, of course I'm not going into the configuration because their configuration was higher on the RAM side, by the way. Okay, as a matter of fact, it was higher on the side of RAMs and all, but still it got sorted out in 23 minutes. You're talking about almost 1/3 time and almost 1/10 of resources, physical resources. Of course, your RAM and other thing goes up, but way lesser as compared to the overall cost perspective. I would like to stop that discussion right here because, you guys are mature enough, you guys are, uh, professional enough to understand the implications of it, right? So these are some of the facts, and because I'm a technical person, I would like to speak more on the technical side there, right? So this is something which, of course, as I told that they were a bit higher on the RAM side, but then it brings the next question altogether. And I think some of you guys were asking this question, right? Well, it is in memory processing you're talking about, Vishal. So it means if it is in-memory processing and well, I'm having a data node or I'm having a cluster wherein the data is like 10 terabyte on every node, or if not 10 terabyte, let's say 200 GB data is there per node. Can I do in-memory processing? Or the simple answer is in-memory processing is gonna fail, Vishal, because I'm not going to definitely have that much amount of RAM, right? It's a very valid question. So the answer comes that it's a misconception that Spark is only for in-memory processing. And this is where Spark gives you the real boost altogether. So it's not like a binary state that wherein either you do the in-memory processing, okay, either you do the in-memory processing or the program fails. It's not about that. In fact, okay, uh, in fact, let me just tell RDD, which I was mentioning some time back, RDD, resilient distributed dataset, they do not, I repeat, they do not hold any data at all. They do not hold any data. They just represent the computations altogether. Okay. Now, coming back to this. So the thing is, when it's like when you decide to cache some data, when you decide to store some data in memory, you can do that. If you don't want to, it's your choice, completely your choice. You can see when I'll run one program. Okay. So this is something which is beauty. Now the second thing is, even if you decide to store the data, okay, and you do not have enough amount of memory available, Spark is not going to let your program crash altogether. Okay. You can provide the options like I want 100% data in memory, then everything is in memory. You have limited amount of memory and then you have good amount of disk. You can probably say 70% data in memory, 30% data in disk, or vice versa, or whatever it is. According to whatever option you have chosen, the performance tunes up or tunes down. And in performance language, we typically call it as graceful degradation or graceful upgradation of performance. It's not like either you have a very good performance or the program just sucks. It would never happen, right? So just to give you, because there is, if I have to go into the depth of it, there are like quite a lot of factors, but yes, I hope it should be giving you some idea that yes, there is a flexibility factor which comes along with it, right? All right, next. Uh, so, you know, the USP of Hadoop, what is the USP or one of the reasons of Hadoop being popular, at least among the programmer community? The biggest USP is that it opens up its power of processing, not just to the Java developers. As I gave you the example of myself, I have written the program in 8 languages. Apart from that, you can, okay, apart from that, um, the people, let's say, somebody who is from SQL background, they can use Hive. Somebody who is coming from the data flow kind of a background, they can use Pig, right? So all of these are the different wrappers, right? All of these are the different wrappers. It's not just HDFS or MapReduce guys, as Vikrant and others were typing. No, they are the core components. But the main reason of popularity is that via different wrappers, which are targeted for different kind of background of people, it opens it up, right? That is one of the main reasons of its popularity. And Spark is also Spark follows the very same footsteps. It is not like you just use some core Spark API and then only you can write your program. No, there is something called Spark SQL. Well, time doesn't allow me to go into that depth because we are limited with 1 hour. But just to tell you, the biggest USP of Spark SQL is you can use the very same Hive query. When I say this, I literally mean this. The very same Hive query which you have used in your, let's say, normal Hadoop project, unmodified, just to see that it runs several times faster. Okay, well, that's all I would like to say at this point of time. Okay, so Spark, gives you those kind of capabilities for the structured data analysis. MLlib, well, about MLlib and graphics, I would like to tell you right now. MLlib and graphics, so MLlib is the machine learning library. It's similar to like Mahout, which you would have heard in Hadoop ecosystem. And those people, if they have used or they are following it, you must be aware Mahout has not seen the recent releases because people are right now focusing about migrating its capabilities to MLlib just to make it faster. Okay, but anyway, coming to this point, it's a machine learning library, and at the same time graphics is more of a graph computation API for from Spark. Okay, these two releases are not the alpha releases as of now. Okay, they are pre-alpha releases, means the developer APIs are open and they are subjected to change. In fact, they are changing. Okay, so they are not yet used completely into production. They are like into the soft production and or the not so mission critical kind of thing. But yes, very soon, like after the support for R is completed, we are definitely expecting MLlib to mature. It has already reached to a certain stage, and eventually graphics also good. So when it comes to, and then if you have the data which is coming in the form of streams and all, you can use Spark streaming to process that data. So this is where Spark basically comes in the direct competition of something called Storm, Apache Storm. Okay, so these are the various components of Spark. Apart from the core Spark API, in which you can write the programs, you can use Spark altogether. Okay, some of the slides wherein I would say, since there is no concept here, I would like to skip or rather than skim through them very fast. Uh, the gist of the slide says Spark, of course, is being talked quite a lot. As it happens with many technologies, it is more of a hype also. People create a lot of hype, but I'm not saying the same thing about Spark. It's not just the hype, of course, it's the kind of capabilities which it brings on the table altogether. So as you can see, most of the industry right now talks about, if they are still in the phases of evaluation. um, Many people are talking about like streaming and other aspect. So people are still in the very early stages of adoption. I think Bhavik says, so Spark is not part of Hadoop ecosystem. Spark was developed separately, but now it sits pretty well in the Hadoop ecosystem as a processing model. Okay, as a processing model, it sits very much into the Hadoop ecosystem. To answer Bhavik. Okay, from the use case perspective, well, the most important use case is by the BI guys, and then data warehousing guys use it because of the popularity of Spark SQL coming into picture. And then eventually, you know, like some sort of log processing or recommendation systems. Well, I don't really agree with these recommendation systems because they are not really production recommendation systems as of now. They heavily use MLlib, and then at least in my experience, I might be wrong, but whatever experience I'm carrying, I have seen those code still changing very, very frequently. The only thing is, since the speed is so fast that people are ready to bite the bullet just because if the re-implementation cost is not that high. So people are still ready to explore them. But yes, once MLlib matures, you will see a lot of surge in this direction. You'll see a lot of surge in the direction of this. User facing services and all. I would really not go to the lower pyramids, but yes, highly used in the area of BI, data warehousing, log processing, recommendation in systems and all. So you guys are all working. You guys are all working in the different uh, domains, and that's where I'm not going into any domain specific kind of example. I'm going into the different areas of example altogether. All right. Who is using Spark? Well, I should not talk much here at this place. The very fact that there are guys who are attending this webinar is a testimony that it is either being used or is people are considering to use it. Well, the only difference here probably between these companies and the others is that many of them are active contributors back to Spark as well. Again, I would like to go through this very, very quickly. It's so definitely like in past also you must have heard about several technologies, right? Uh, right now, if you just talk about big data, you will see several thousands or hundreds of thousands of links altogether. Databricks, well, Satyanarayanan, the Databrick was the inventor, or that company has started it. Eventually, they donated it to the open source community. Okay, so it's a different thing. Just like Cloudera has developed Kudu. Has anybody heard about Kudu? Okay, Kudu is, you can say that, the next version of HDFS. Okay, it is typically used for the very, very fast storage and access, random access of the data, and it is going to be adopted by Apache. I'm not sure how many of you have heard, or I don't want to go in that direction, but yes, it's one of those kind of technologies, right? So this is something wherein Spark altogether, it's not one of those passing phases altogether. It has already proved its value, and it's like being widely adopted. Number of Spark contributors and all, I'm sure if you go right now, you'll find more data, way more number of users than whatever is written on this slide. So that's like, it's a public knowledge anyway. I was waiting. I was waiting for this slide. Okay. Well, after this hands-on, because I'm sure after hands-on I'll be left with a very small amount of time. Okay. So those people who would probably, if you feel excited enough, or if you find a good motivation to go with Edureka, with the, you just want to see what exactly are the offerings from Edureka, what exactly is the coverage wise, what are we covering and what we are not covering as well. Everything is available online, edureka.co. That's a URL. You can always go there. You can just try to get more details. And if this excites you, we'll definitely meet in one of the classes or one of the batches there, right? Well, after this, I would like to go directly to that comparison part. Okay, and with this, I definitely don't want to rush it out. So if it is okay that I would overstep by 5 minutes or probably 10 minutes, I hope that should be okay with you guys, right? Okay, with this, let me directly go here. So again, let's let's just talk about that very same word count program, right? No discussion about the algorithm. No discussion. You guys have already seen the example, right? Well, this is a more, I would say, more organized kind of a program. Again, this is just for reference. I'm not going through the code and the algorithm here. No, that's not my intention. Probably you write a separate mapper, you write a separate reducer, then you typically write a driver class wherein you are going to tie everything together. Well, if you just count the number of lines, it is like 60 plus 24 is 84. 84 plus 20 is like 100 plus lines, right? Including import statements, including everything, right? So this is the minimum number of lines which you need to write a production grade kind of a program, a MapReduce program. This is right now just from the development perspective, right? And I'm sure everybody is aware of the word count problem, and hence I'm assuming that I don't have to explain you what I'm trying to achieve altogether, right? This was just for your reference, right? So now let me tell you my plan. So this program of word count, which is known, I have already written. I have kind of created the jar for it. Let me run this program on a sample input of data. Let's see the size of the data. Let's see, you know, uh, by running it, the obvious output of it, right? And then let's take it from there, right? And then attack the very same thing using Spark on the same amount of data, and let's see the performance. So that's the line of action where I'm going. Uh, okay. So just a second. Uh, yarn jar. Yes. So that was my jar. Anyway, I don't want to run it directly. Guys, first let me tell you how does the data look like. And the location which I'm using is an HDFS location. So by the way, this is my virtual machine, and it probably would be running faster because I'm using my MacBook, which is having 16 GB RAM. Might not be applicable for you. Depends on it, right? So anyway, um, I think, okay. Hey Pramod, my name is Vishal. So I think Pramod just joined and he just wanted to know my name. Vishal Kumar. And now, so this is the place wherein, let me just show you. This is a fabricated data. I have created it. So Vishal, what is this? Vishal, Vijay, B, and I have copy pasted it. Okay, fine. Looks like a very crude kind of a file. How many number of records are we talking about? Can you see the number? 393,216 records. Is everybody able to see that? Right? I hope it is decent enough for a single machine. I hope you guys will agree, right? This is decent enough for a single virtual machine, right? So now my idea is, of course, whatever I will get in the output, the idea of validation of my program is, if I run my program, in the output, I should just be getting 3 words. Sorry, 4 words. Vishal, Vijay, and I think B, or whatever it is, right? And then whatever is their count. Right now, we are not interested in that, right? So now, with this understanding, I'm going to run. So I basically the program, whatever I showed you, I kind of exported it. I created the jar out of it. I'm not going to take the time on those lines. And then that's a standard yarn command. Yarn jar, whatever jar you have created. Then this is the location of input. And then yarn underscore OP is the location of output. Okay. I hope so far so good, right? At the same time, let me just open up my cluster also. So this is my yarn cluster. You can see, of course, I have already run this program once. Okay. Now, I'll just go ahead. We'll fire it up. We'll go here. You can see this. This program is accepted. Sorry. It is running. Control R. Running. Right. Finished. Looks like it is finished. Go there. Well, it's good. Can you see the time? It is fast, right? Well, my machine is high RAM right now. So my executors and everything are on the higher side. Did everybody see the execution time right now? May I get a very quick confirmation? Right? What is it? 18 seconds, right? Fast. Looks like it is fast. By MapReduce standards. Okay. Uh, let's see the output. Vijay, Vishal, B. These are the only 3 words, right? That's what we were expecting. Fine. Let us now, I'm just a second, guys. Exit. Let us now open up Spark and then try to achieve the very same thing with the very same input in Spark and see what is the performance, right? So with this, let me directly, I have multiple options. I can run it as an application. I can run my program as a Spark shell, interactive. I feel probably interactive program would be helpful for you because that way you will be able to understand what is happening line by line. Making sense? Right? So I will open it up here. Spark 1.4. No. I have kind of messed up my 1.4. I will go to Spark this cd bin. So guys, I'm going to I have like multiple installations of Spark with me, and I'm going to Spark shell. When you will do this, it will invoke the shell for you. Do you need to stop yarn.sh? No, Bhavik, not at all. Okay, so coming here, that's my Spark shell, ready with me. If you guys are noticing, it's kind of a prompt with Scala language. So the program which I'm going to show you will be the Spark shell program or the Scala program. Now, just to make sure that you guys are comparing apples to apples, can you guys see what was my input? Hello Spark input, right? User Vidhyani input directory, Spark input, hello Spark. I'm going to use the very same thing even for Spark also. This is the very same thing with Spark, wherein I have kind of used the very same file. I'm defining that file. And then right now my intention is not to go into the syntax, but this is where the tokenization happens. This is where we are doing the tokenization of the words. And well, I'm writing these 3-4 lines because I want to explain the things. Otherwise, I'm not sure whether you'll believe me or not, but I could have written this entire program in one line, single line altogether. This is where I'm purposefully saying that it is the output of mapper. I don't actual program when I will write in the batches, I will be writing it in one line because we would have covered Scala basics before that. And then it's like reducer output, wherein I'm just defining them. No processing has happened so far. Now is the time wherein I go, and guys, after this, actually the execution will start. So I'm going to fire it now, and I'm saying output, whatever that reducer output will be, do a for each println. Enter. I hope everybody realized that I use the same input, same machine. How much time did it take? 0.064 seconds. I'm not saying 0.64, 0.064 seconds time. What was the time which you saw earlier? What was the time which you saw earlier? 18 seconds. What were the number of records? 393,000 some odd. You guys are smart enough to understand the difference altogether. System configuration for Spark installation, guys, It's the same. For me, it's the 4 GB RAM machine which is running. Satyanarayan. It's the same machine. So if you think that way, Satyanarayan, it's like it's a data node with 4 GB RAM where everything is running, right? Beat Spark, beat Hadoop. Guys, that's all I had to say at the last from the hands-on perspective. Geetanjali, you are asking about the Python code. All of this material with the recording would be shared. So you'll get everything. Guys, I hope this was a good usage of your last 1 hour. I hope you are not disappointed that you spend some time, and again, my intention is not to make it a marketing pitch. I'm not a marketing guy. I'm a worker just like you. Okay. So with this, why did you use Spark or Scala language? I chose Scala language because Spark is written in it. Simple as that. And it is one of the most optimized way, or it is one of the languages which supports object-oriented programming as well as the functional programming both. Okay. And well, there are other reasons. I would not really go there. Okay. With that, guys, I would like to take your permission. I hope you enjoyed it, and would if you have more questions, you want to know more about course syllabus and everything, well, I just showed you that if you go to edureka.com Apache Spark Scala training, just go there. You will be able to get more details. You can pose your queries as well. With this, guys, I would like to take a permission. Bye for now.